Hi everyone, and welcome to the Place Value series here at Linear Abacus. In this video, we're going to learn how to make sense of the different representations of number. So let's get started. Meet our team. This is Oscar, Darren, and Peach. They're going to explore why we write and read numbers the way we do. We will begin by choosing a bead on the Linear Abacus. I wonder how I could name this collection of beads.
We could count each bead one at a time till we reach the question mark. Like this. 1, 2, 3, 4. $67, $68.
That's one way, but it took a really long time. Why don't we try counting the rows of colour? 10, 20, 30, 40, 50, 60, 65, 68. This collection can be called 68.
We could get there a different way. I saw 4 blue rows and 3 yellow rows, and because I know that each row has 10, this is a total of 70. Notice that the last row didn't use 2 of the beads. This means I can count back 2 from 70, 69, 68. I still get to the 68th bead.
Well, this is great! So when I say 68 and when I write 68, I can talk about the total and I can point to this place in the order. However, I still don't know why the digit 6 is in the numeral or why the digit 8 is there. What could these digits mean?
That's a good question. I know these digits are definitely not talking about individual beads. It cannot be 6 beads and 8 beads.
What if we tried folding the beads? I like how Oscar counted by tens. If we leave a space between each 10, we have enough room for a fold.
What a great strategy! This is how we make the base 10 groups. We just need to remember this rule, that when we count 10 individual beads, it becomes one group of 10 in the next place.
One group of 10, 2 groups of 10, 3 groups of 10, 4 groups of 10, 5 groups of 10, 6 groups of 10, and 8 ones. Well, that's cool. I can see that these folds make 2 rectangles. One rectangle shows the groups of 10s, and the other shows the groups of 1.
We can label this model differently. In this rectangle, I can see 10 6 times. And in the next rectangle, I can see 8 groups with 1.
I think I can explain what the digits mean in the numeral. I can use a number sentence to show my thinking. To help you follow along, I will use different colors for different numerals. When I want to talk about the size of the group or the number of beads in each fold, I will use a red numeral. On the model, I can see a group size with 10 beads and a group size with 1 bead. When I want to talk about the collections or the number of groups, I use a blue numeral. On the model, I can see 6 groups of 10 and 8 groups of 1. The first rectangle shows 6 tens. We can write this as 6 times 10. And the next rectangle shows 8 ones. We can write this as 8 times 1. To name the bead in this collection, I have to add the 2 rectangles. I can use brackets to separate the rectangles in the number sentence. This way you know what I'm calculating first.
This tells me that the digits in the numeral are actually names of the factors. This means the digits are the blue numerals, which means 6 times and 8 times. You're right, Peach. They do not represent individual beads.
Well done, everyone. You have used a mathematical argument to prove that this bead is called 68. And now it is clear that when we write numerals in base 10, the digits act as factors. In this example, the digits show how many groups of 1s or 10s are in a collection. So now it's your turn. Choose a random bead on your abacus string and give this a base 10 name. And be sure to match your thinking with a mathematical argument and think creatively. Thanks for watching, and we'll see you next time.